All right, we're going to look at relations and figure out which ones can be defined as functions. So if you take a look at the first statement, some relations have a certain quality that makes it a function. Examples of relations that are functions and relations that are not are shown below. Examine these relations and determine what makes it a function. So we're going to, basically you can see two columns here. First column, relations that are functions. Second one, relations that are not. And we want to try to come up with reasons why they would be in these categories. So first two in each are sets of ordered pairs. So take a look at the x values. So 3, 5, -4, 7, they're all different. Y's are all different as well. That's considered a function. Next one, the x's are all different. The y's are actually all the same, but it's still considered a function. Okay, take a look over at the right. So the x's are not all different. So when x is 3, the y value could be 4 or 2. Here, these all have the same x values. So for the x value 5, there's a y value of 2, 3, and 4. So that's saying to me that for every x, there can only be one y value, right? So for this x value, there's 2 y's. For this x value 5, there's 3, and that's not a function. So let's just continue down and look at the arrow diagram. So here, the domain 1, 2, 3, 4, and the range 8, 10, and 12. So this one for 10 is the range value for two different domains. And that's a function. Over here, we have just 3 domain values and 3 range. But for the domain value of 2, it could have a range value of 10 or 12. So again, that same property is that for this domain value, we don't know if it's x or what the variable is because it's not labeled, but for the domain value of 2, there's 2 different range values, and that's not a function. If we look at the table of values, we've got number and the type of number. So they're listed there. So 3.6 is rational, and so is -7/4. Here, irrational and irrational, those are the same, and we've got 2 different numbers there. Okay, and again, this is considered not a function. In a graph, we've got some points here. So for every x, you'll notice that there's just one point for that particular x value. Over here, same until here. When x is 3, there's 2 different y values, and that's not a function. That's for discrete data. For continuous, for all of these x values, there's just the one y value on that semicircle. Here, for, say, an x value of -1, there's 2 y values. X value of 0, there's 2. X value of 1, there's 2 of them. So for every x, there's only there's 2 y values, which is not a function. So that's really what it comes down to. For every domain value, there's only one range value. So you can easily see if it's not a function by looking for repeated x's and different y's. Saying that can't be how you define it. You need to say for every domain value, there's only one range. So a function is a relation where each element in the domain is associated with exactly one element in the range. Okay, so a function is like a machine. For each particular input we put into our function machine, it will only generate one output. So you put a value in and you get only one out. You don't get 2 different out. There's not 2 spouts on the machine. So for example, if our function is expressed as an equation, then the function machine would work as follows. So if we put 7 in, then the 7 is going to go in for x. 5 times 7 is 35, plus 3 is 38. Okay, the domain or input value of 7 would produce exactly one range or output value of 38. For this function, x is the input and y is the output. The input is always the independent variable and the output is always the dependent variable. What comes out of here depends on what was put in. Okay, so some terminology for you. So question 3, if a relation represented as an arrow diagram, then it's a function if there's only one arrow for each element in the domain in the first oval. So this is a function, there's only one arrow coming from each of these. If there's two arrows coming from a value, then obviously there's going to be two different y values, so that's not a function. So that's an easy way to check. If a relation is represented by a graph, then it is a function if there's no point directly above or another point or below, whatever your reference is, of the graph. A graph represents the function when no 2 points lie on the same vertical line. So sometimes you will see it defined below. We'll call it a vertical line test. So if I pretend that's my pencil, and I'm moving that along the graph, anywhere I move it, the graph only touches the line once. If I go over here, touches once there, but then twice everywhere else. So this is not a function. So you can use the vertical line test to help you if you have a graph. So if it is not possible for a vertical line to intersect the graph of a relation more than once, then the relation is a function. It's a quick way to see if it's a function or not. It again is not the definition of a function. Definition is back up at the top. Oops, I guess it's the previous page. Each element of the domain is associated with exactly one element in the range. Or you could say for every domain value, there is only one range value. So maybe I'll write that in for every domain value, there is only one range value. Okay. And then it gets you to the practice. So it's a short lesson. Okay.